We'll finish off this section on introducing linearity and linear models by looking at a closed form formula for linear functions or linear models. In the last video, we ended by looking at this World of Warcraft example, and what we did was we started with 45 experience points, and the higher the character level went, every time we added a character level, we added 5. How did we do that? We took the previous number of experience points, if it was, say, 65, and then incremented it up to 70, then from 70 to 75. That's called recursive. Recursive methods use the previous results to get the next results. Instead, a closed form formula is a formula where you just plug in the value of x and you get the value of y. For linear functions, you've probably seen the form of a closed form formula before, and that's our old friend y equals mx plus b. We're going to explore what that means in this video. In this case, m, for some historical reason, I don't know why, stands for the slope. What's the slope? Well, recall that's that rate of change, right? How much you change your y value when you change x. B, on the other hand, is the initial value. That's the value of y when x equals 0. So let's look at our World of Warcraft example and figure out how to write this equation in that case. So just to remind you, the World of Warcraft example modeled how many experience points a player gets when they kill a mob whose level is equal to their own, right? And these mobs are this is limited to the Eastern Kingdoms. They might have different parameters in different parts of the world. So anyhow, when you start, if you're level 0, you get 45 experience points for killing another level 0 mob. And then for every level your character goes up by, the experience points increase by 5. So what does that mean? Well, since at level 0, we start at 45, that's our b, our initial value. And then since we go up by 5 for every level we go up, that's our slope, that's m. So the equation with m equals 5 and b equals 45 would be y equals 5x plus 45. Now, instead of y, I'm using xp for experience points because that's more informative. Instead of x, I'm using character level because that's more informative, cl. And I actually wrote it as b plus mx instead of mx plus b. I wrote it as 45 plus 5cl. I tend to write them like that because I like the thinking of we start at 45 and then we add 5 cl's. So where does mx plus b come from? Let's take another look at this example, and we're going to go back to the data we generated in the spreadsheet. In the spreadsheet, as I mentioned earlier, we generated these data recursively, but now we can think about what this means. So here's my x value, character level. Here's my y value. How would we get this y value? We start at 45, and then we kept adding 5. How many times did we add 5? Once, twice, 3 times, 4 times, 5 times, 6 times. So we started at 4 and added 5 6 times. Well, adding 5 6 times, that's the same as adding 30, right? Adding 5 plus 5 plus 5 plus 5 plus 5 plus 5 is 30. That's the definition of multiplication as repeated addition. So right there, you can see 45 plus the character level times 5. Similarly, I'll go down to 12. How many times do I add 5 to 45 if my character's level is 12? Why, 12 times. Well, what does that mean? Well, that means I take my 5, I multiply it by the character level 12, and that will get me 60, and then I add that to 45, which is where I start from, and that gets me 105. This is exactly what this equation tells you to do. It tells you to start with 45, and for every character level, add 5. So whatever your character level is, the total number of times you add 5 is CL, and you accomplish that through multiplication first, and then you tack it on. The same thing is true in general for y equals mx plus b. You start with b, and x tells you how many times you add m, and you just put those together. Word of caution here, m could be negative, so you could be subtracting a number x times. And the other thing to just be aware of is x may not be a whole number. right? But the same principle works. Let's return to the straight line depreciation example that we started the last video with. So this example we noted was linear because it has this constant absolute change. Every year that the machine ages, its book value declines by $2,800 as a result of expensing it. So what does that tell you? That tells us that the slope, our m, is negative 2,800 because the book value goes down. What do we start with? Well, we start with 75,000 for our book value because that's what we purchased this thing for. So for example, in year 6, we subtract 2,800 6 times. And then subtract that from 75,000. So we multiply 6 times 2,800, subtract the result from 75,000, and we get 58,200. So right away, we see we start at 75,000, so that's our b, and we decrease by 2,800 for each year. That's our slope, m, and it should be negative 2,800. There's a typo there. And therefore, the book value, which is our y, equals 75,000 minus 2,800t. T is the age of the machine, and we can think about that as our x. In the next section, we're going to dive deeper into detecting linearity from data sets, from verbal descriptions, and in other different representations of these functions.